NASA just shattered its own master plan. For over 10 years, the goal was simple: build a massive orbiting space station around the moon. But behind closed doors, a forensic audit has forced a brutal reality check. The station is unraveling, and the space agency is suddenly pivoting every single dollar straight to the lunar dirt. Why is NASA suddenly abandoning a space station they have spent a decade planning? Because the metal is literally degrading before it leaves Earth, and the crushing weight of the modules has pushed the timeline past the breaking point. So, where is that $10 billion going now? It is being violently redirected into a Phase 1 deployment strategy. Instead of floating safely in orbit, they are dropping 25 rockets and 21 automated precision landers directly on the most dangerous terrain we know, the lunar South Pole. But this raises a massive existential question. How will these new machines survive in deep freezing craters without the safety net of an orbiting command station? The answer lies in machines that don't drive but jump, and machines powered not by the sun but by a beating nuclear heart. To understand how high the stakes really are, we didn't just read the press releases, we analyzed the forensic engineering reviews of the Gateway timeline, ran technical simulations on propulsive hopping in zero-atmosphere environments, and validated the data on nuclear thermal survival in shadowed craters. This is the exact anatomy of NASA's $10 billion scramble. You don't just throw away a 10-year, multi-billion dollar blueprint on a whim. So, what exactly did the engineers find hiding inside the station's core that terrified them enough to pull the plug? To comprehend the absolute gravity of this pivot, we have to look at the forensic engineering review. NASA executives ordered a deep dive into the Gateway's production line. What they found was a relentless, compounding disaster. The two most important pieces of the space station, the module that provides the engine power and the module that keeps the astronaut breathing, were dangerously behind schedule. The core culprit: corrosion. The specialized metal selected for the main pressurized shell, the very walls meant to protect human life, started suffering from severe, unexpected degradation right on the factory floor. Engineers were forced into a defensive loop, patching, mitigating, repairing. Every fix added weight. Every pound of weight added complex math to the launch sequence. By the time the audit was finished, the math was clear. The space station was mathematically incapable of being ready before the year 2030 at the absolute earliest. Space exploration does not bend to political promises. The physics is absolute. Forcing a modern, multi-ton lunar lander to dock with a delayed, overweight space station introduces a stranglehold on the fuel supply. It was a trap. So NASA executed a scorched-earth strategy. They took the $10 billion, stripped the program of all its orbital illusions, and initiated Phase 1. Between now and 2028, they will launch an unprecedented surge of heavy lift rockets. Every single microton of hardware will bypass orbit and be delivered directly to the airless, violent regolith of the moon. But if you are abandoning the safety of an orbital base, every machine you drop on the surface must be entirely self-sufficient. And the first scout they are sending is walking straight into a geometric trap. Meet Viper, the Volatiles Investigating Polar Exploration rover. This isn't a standard rover happily rolling across flat sunlit plains. Viper is a 450 kg robotic prospector. Its entire mission is to plunge into the pitch black, permanently shadowed craters of the South Pole to hunt for frozen water. It carries 3 distinct chemical sensors and massive mechanical drill capable of piercing the highly abrasive frozen subsoil. Water is the ultimate prize. If you have water, you can make breathable oxygen and rocket fuel. But there is a fatal flaw in the Viper's design. It has wheels. The lunar South Pole is a nightmare of jagged rocks, steep cliff faces, and hidden sinkholes of fine dust. When terrain conditions present a severe unyielding blockade, a wheeled rover is trapped. One bad calculation, one stuck wheel, and $1 billion mission ends in silence. Viper must constantly recalculate, drive around obstacles, and lose precious time. It is a slow, methodical machine in an environment that demands rapid, aggressive mapping. NASA quickly realized that if they wanted to map the worst terrain on the moon before the 2028 deadline, they couldn't rely on something that drives. They needed a machine that could simply ignore the ground entirely. How do you safely explore a crater that is too steep to drive into, on a planet that has absolutely no air to fly a helicopter? You introduce an entirely new class of machine, the MoonFall Drones. Since there is no atmosphere on the moon, wings and propellers are useless. You cannot fly, but you can jump. These drones reject wheels completely in favor of an independent, propulsive hopping architecture. Imagine a robotic probe. It initiates a launch sequence, blasting a blinding white jet of thrust from its main engines. It leaps from the dusty floors, reaching an altitude of 1 full kilometer into the black sky. It arcs over the unyielding ridges of a crater, scanning the ground with ground-penetrating radar and optical cameras, capturing data that a wheeled rover could never reach. The flight envelope is incredibly violent. From ignition to touchdown, each jump lasts exactly 150 seconds. But landing on an airless world is a brutal physics problem. There is no air resistance to slow you down. If the drone simply falls, it shatters into 1,000,000 pieces. To survive, the drone's internal brain must run automated guidance loops, recalculating its engine thrust millisecond by millisecond. It must fire its engines at the exact perfect microsecond to counteract gravity, bringing its horizontal and vertical speed to absolute zero at the exact moment its legs touch the regolith. By stringing these 150-second jumps together, a single MoonFall drone can cover 50 kilometers of the most treacherous terrain in the solar system, doing in hours what would take a rover months. Jumping over craters solves the terrain problem, but it doesn't solve the monster waiting in the dark. What happens to these machines when the sun actually goes down? Every single automated asset deployed in this $10 billion scramble faces an imminent existential threat: the lunar night. A single night on the moon lasts for roughly 14 Earth days, over 300 continuous hours of absolute, unrelenting darkness. Without the sun, the temperature plummets so fast and so deep that it alters the physical state of metal. Standard lithium-ion batteries freeze solid, circuit boards snap. If a rover relies only on solar panels, the lunar night is a guaranteed death sentence. To dismantle this barrier, NASA had to overhaul their power grids. They are executing critical demonstrations of the RHUs, radioisotope heater units. We need to translate what that actually means. An RHU is a compact pellet of decaying nuclear material. It doesn't generate electricity, it generates pure, unstoppable heat. Imagine taking a fragile glass greenhouse and dropping it into the middle of a deadly pitch-black Arctic blizzard. It should shatter. But inside that greenhouse, you place a small, eternally glowing thermodynamic furnace. The outside of the glass can be buried in 50 feet of jagged ice, but the inside remains perfectly warm. That is what NASA is doing to their rovers. They are burying a permanently glowing nuclear ember inside the heart of the spacecraft. Validating these nuclear hearts is the absolute prerequisite for survival. It is the only way these machines can endure the 354-hour freeze, wake up the next morning, and continue the scramble. We stand on a precipice. The transition away from the orbiting space station has shifted the entire global landscape. By 2028, this network of jumping drones, nuclear rovers, and automated landers will establish LunarNet. a massive data throughput system beaming 500 megabits per second between Earth and the Moon. It will transform the South Pole from a silent crater into a highly connected industrial highway. Whoever controls those physical nodes and data links over the next 2 years will completely dictate the terms of planetary development for the next 50. NASA had to reckon with reality. They sacrificed the illusion of an orbital base to secure the actual ground. But this raises a darker, more complex issue. By abandoning a centralized government-controlled space station, are we simply handing the sovereignty of the Moon over to the private corporate contractors who are building these landers? That is exactly what we are going to dissect in our next briefing. Until then, stay analytical and stay curious.